Hey, good morning, everybody. So, going to go through the 5.4 notes here today, and just wanted to highlight something real quick before we get started. Number one, the last 2 days we have worked on substitution. Now, as I mentioned before, there are three different possible answers that you could get. You could obviously get one solution, okay? You could end up where you get no solutions, all right? Or, ooh, that's not very good handwriting. Or the third scenario is that you could have infinite solutions, right? And when we actually solve a system of equations, what I would recommend is using this particular type of method, the substitution that we've used for Monday and Tuesday, only when you have an isolated variable. Now, you could use it for any system of equations, but it might be a little bit more difficult for those others. Now, the method that we're going to use today is called elimination method, okay? And that is best used when you have standard form, where there's no isolated variable. So what I mean by that is isolated variable, it says y equals mx plus b, right? Where like y or x is on a side by itself. Elimination is where it looks like this. Standard form, okay? It's easier to use elimination for those methods. Now, when you solve by elimination, you need to have the same coefficients but opposite signs for the same variable. So think about that. What is the inverse to positive 2, right? The inverse of positive 2 is a negative 2. So when you're looking for, in a system, how to use elimination, you have to look for inverses, like 2 and negative 2, or 3 and negative 3, okay? One thing to remember is that when you multiply an equation by a number, like up here, where it's saying quick check, when you multiply an equation by a number, you will get the same line, okay? So what I mean by that is, let's say I have y equals 2x plus 4. Okay, well, you can see that line right now. Now, if I multiply all three of those terms by 2, so 4x plus 8, okay, you can see that no matter which line I pick, they are the exact same line because I multiplied every single term by the same number. So it doesn't actually change the line, it's just rewriting it, all right? However, if I don't multiply everything by that same number, so let's say, for instance, I do 2x plus 4 instead, or 2x plus 8, so I've multiplied the first and the third, notice how the green line is a different line. Okay, so that tells you everything you need to know. You can multiply by the same number and it's still going to work out. Okay? All right, so that's important because with the elimination method, that's exactly what we're going to do. So for example, number one, look for inverse variables. So in this case, we have negative y and positive y. All right, so those are inverses. Perfect. So when you have inverses, you just add the two equations. So x plus 2x gives me 3x. And since these are inverses, they cancel out and give me 0. Okay, and then 11 plus 19 gives me 30. So as you can see, the word eliminate, we eliminated the y values. And so now I just have this x value to solve for. Okay, but remember, that's not a solution. The solution to a system is a coordinate point, so we need to actually plug it back in. So I'm just going to use the top equation, but you could use the top or the bottom, but I'm going to use the top. So we have 10 is x, a negative y, and that's all equal to 11. Okay, I'm going to subtract 10 from both sides. Gives me negative y equals 1, and then divide by negative 1. Y equals a negative 1. So my solution to this first example would be 10, negative 1. Okay, and that's how you use elimination. You add the two equations and eliminate a variable. So example 2 is a little bit tougher of a tier. Notice there are no direct inverses. 6 and 3 are not inverses. These are not inverses. Neither are these. However, if I made this one positive, it would be, right? So that's what we're going to do. To make it positive, you multiply the whole thing by negative 1. So I'm going to distribute. So negative 1 times negative 6. So I'm going to rewrite it down here, actually. So negative 1 times negative 6 gives you 6x. Negative 1 times 6y gives me negative 6y. And negative 1 times a positive 6 gives me a negative 6. Okay, so now I don't need this anymore. Okay, I'm just going to use these bottom two, and I'm going to add them together. That's elimination method. You do it once you have inverses, which is what these are. Okay, so I have 0, because they cancel out, minus 3y equals negative 12, and a negative 6 is a negative 18. Notice I eliminated my x variable this time, so I'm going to solve for y. Perfect, so y equals 6, and now I'm going to plug it back in. For the y, and solve for x. Stylus is acting weird. Okay, so negative 6x plus 18 equals negative 12. Okay, divide by negative 6, divide by negative 6, x is a positive 5. So my answer here, 5 comma 6. Now, if you are curious if you got the right answer or not, there is a way that you can check it. Take your equations, plug them into Desmos. So for instance, in this example, example number 2, we want to see if 5 comma 6 is the solution. We're going to plug it in. So negative 6x plus 3y equals negative 12. So if you're at home, this is a great way to see if you're getting the right solutions, or to see what the solution should be, so that you can do those later. Minus 6y equals negative 6. And our solution is, right where they touch, that's 5 comma 6, which is what we had. Perfect. Okay? All right, let's keep going on. So they're going to get a little bit tougher here. Example 3. Again, no inverses. But if we multiply 2 times 2, that would give us 4. Now, one has to be positive, one has to be negative, so we're going to multiply it by a negative 2. Okay, and I'm going to rewrite it down here. So that gives me negative 4x minus 6y minus equals a negative 2. Okay, and I'm going to add these two. So these give me a 0, they cancel. This gives me negative 8y, and this gives me a positive 8. All right, so that eliminated my x value, so I'm going to solve for y. Okay, and then again, to finish it up, plug it in. So 4x minus 2 times y was negative 1 equals 10. Subtract. Divide. 2. So our solution, 2 comma negative 1. All right, and feel free to speed this up if you need to on YouTube, or you could also, slow it down or pause it if you need to as well. Okay, next one, same thing. These do not eliminate each other. Neither do these, neither do these. Now, here's the thing. Notice that in this case, I have x and y on opposite sides. This one, they're on the same side. Okay, so I need to put them on opposite sides. So I'm going to take this 6y and I'm going to move it over. Okay, so that now gives me negative 4x equals negative 6y plus 3. Okay, so now I have these two equations. Now again, they still don't cancel, so I'm going to multiply this one by 2, and that should get these two to cancel, right? Okay, so I now have negative 8x equals negative 12y plus 6. Okay, and I'm going to bring, so we don't need this anymore. And I'm going to bring this one down so it's right on top of it, that's all. So 5x equals 12y minus 6. Okay. So, all right. So I have negative 3x equals 0 plus 0. So negative 3x equals 0, which means when you divide by negative 3, x equals 0. Okay, so I'm going to take that and plug it in. So if x is 0, 5 times 0 equals 12y minus 6. So 0 equals 12y minus 6. Add 6. Divide by 12. And 6 goes into 12 2 times, so this is 1/2. So my formula, or my solution here is 0 1/2. Okay. All right, and then last examples, these are special cases. So that means that they're either going to end up in no solutions or infinite solutions. So let's take a look at the first one here. These won't cancel, but if we multiply the bottom by -2, then it will. So that gives us negative 18x. Give me one moment, please. Okay, and then when you multiply by -2 here, you get 16y, and this gives you -8. Okay, all right, so then bring this one down. Okay, and add them both together. They actually cancel out. So when does 0 equal 0? Always, which means that this is infinite solutions. Okay, and then last one here. Again, they do not cancel out, and this one's a little bit tougher because even if I multiply 3 by something, it doesn't get me to 4, and vice versa. But if you think about their multiples, like 3, 6, 9, 12, 15, 18, 4, 8, 12, notice that they both have a 12 in common. So that's the one I'm going to get at 2. So 3 times a -4 would get me 12, and 4 times 3 would also give me 12. So I'm going to rewrite these below. Okay, I'm going to rewrite this one below. Okay, and then I'm going to add them together. So 0 plus 0 equals 72. So when does 0 equal 72? It does not. So this is no solutions. Okay. All right, so that's it. If you have any questions, reach out to me. If not, go ahead and complete the exit ticket for today, and I will see you guys in school tomorrow.